Good morning. Welcome to the next lecture. Today we are going to introduce a new topic, that is progression. In our daily lives, we usually talk about the days in a week, weeks in a month, and months in a year. All these occur in a sequence such that there is a definite order for the elements. Like the first day of the week being Monday, followed by Tuesday, Wednesday, and so on. In the case of month, see, the first month in a calendar year is January, the second is February, then March, and so on. All these follow an order and it can be termed a sequence. Similar to the concept of sequence, we have another concept of progression. See, a progression is a sequence of numbers where the terms follow a specific pattern or specific rule. And these are often characterized by the relationship between the consecutive numbers or consecutive terms. And it is a collection of objects which is ordered in such a way that we can identify the first member, second member, third member, and so on. So in a progression, each term is related to the previous term in a consistent manner, either in terms of addition or multiplication or maybe based upon some other rules. So there are different types of progression, see, such as arithmetic progression, geometric progression, harmonic progression, etc. See, in this lecture, we are mainly focusing on the arithmetic progression. See, imagine a situation that I hope all of us have hired a taxi to reach a particular destination. So, you know, the taxi charges have a base fare or minimum charges for the first few kilometers. After that, it charges a certain amount per kilometer. For example, say the base fare of the taxi is ₹20 for the first 2 kilometers. After which taxi charges 10 rupees per kilometer. So charges for third, fourth, fifth kilometer will be, it is 30, 40, 50, etc. And we can observe here, these taxi fares form a pattern in which we get a next fare by adding a fixed number to the previous fare. Such a sequence of number is said to be a arithmetic progression. We can define a arithmetic progression is a sequence of numbers which we can also call a term, in which each terms after the first is obtained by adding a constant value to the preceding term. Thus, in an arithmetic progression, the numbers are listed in a specific order in which the difference between any two consecutive terms is constant. That is one of the most important characteristics of an arithmetic progression. That is, the difference between any two consecutive terms is constant. Let me introduce, the concepts of first term and common difference. See, every arithmetic progression starts from a point on a number or a particular number. That is the initial term of an arithmetic progression, which is the first term of an arithmetic progression. And this first term is usually denoted by a letter, that is small letter a. And regarding the common difference, see, the fixed number which is added to a term to get the next term in an arithmetic progression, which is actually called a common difference of an arithmetic progression. So remember here that it can be a positive number, it can be a negative number. That means common difference may be a positive or negative. Usually, the common difference of an arithmetic progression is denoted by a letter D. And the behavior of the sequence entirely depending upon the value of common difference. So if the value of D, that is common difference, is positive, then the member terms will grow towards a positive infinity. And as against that, if the value of d, that means common difference, is negative, then the member terms grow towards the negative infinity. See, for example, we have a sequence of numbers here 2, 4, 6, 8. Here the first term is, that is a, which is equal to 2. That is, first term is the first number, which is equal to 2. And the common difference, that is denoted by d, that is the difference between two consecutive numbers. So here it is a2 minus a1, that is equal to 4 minus 2, which is equal to 2. Similarly, see, consider another two terms, that is 6 and 4. So 6 minus 4, which is again equal to 2. If you consider the difference between 8 and 6, that is a4 minus a3, which is equal to 8 minus 6, which is also equal to 2. And this common difference in an arithmetic progression is always constant. See here, it is 2 here in all cases, meaning that it may remain the same throughout the sequence. And this consistency is defining the characteristics of an arithmetic progression. It means that the difference between the consecutive terms in a sequence is fixed and does not change as you move along the progression. Now let us consider the general form of an arithmetic progression. See, if the first term is represented by a1, see the first term which is represented by a1, which is a, which we are saying that it is a, then the second term will be getting after adding a common difference to the first term, that is a1 plus d, or we can say that it is equivalent to the a plus d. The third term will be a2 plus d. This third term, that is second term plus d, or the first term plus d, which we can say that it is a plus 2d. Similarly, fourth term can be found, that is third term plus d, or we can say that a plus 2d plus d, or it is also equivalent to the a plus 3d. So we can write a general form of an arithmetic progression, that is a, that is first letter or the first term, a plus d, second term, a plus 2d, third term, a plus 3d, and up to the nth term, that is a plus n minus 1 into d. It is nth term will be a plus n minus 1 into d. So here the common difference between two consecutive terms can be seen as a constant. So here, see, we will consider another types of the progression. We have a finite arithmetic progression and we have infinite arithmetic progression. See, an arithmetic progression in which there are only finite number of terms, then we can call it is a finite AP or a finite arithmetic progression, or it is the sequence of numbers where each term is obtained by adding the constant value to the previous term and the sequence terminate after the certain number of terms. It will terminate after a certain number of terms. That's why the arithmetic progression has last term. This type of, that is finite arithmetic progression, has a last term. So for example, consider the height of some of the students in a school standing in a queue in morning assembly are, see, 147, 148, 149 up to 157. See, we have a last term as well here. That means this series is ending with 157. We have a last term also, and which is starting from 147. And the common difference, if you consider here, it is the difference between two consecutive number, then it is equal to 1. Now, as against the finite arithmetic progression, we have infinite arithmetic progression. See, the arithmetic progression whose terms are not finite, which are generally called infinite arithmetic progression, or it is this arithmetic sequence that continues indefinitely without a specific endpoint. That's why such a arithmetic progression do not have a last term. For example, see here 1, 2, 3, 4 up to n numbers. Here we don't have the last term. Or consider another one, 100, 70, 40, 10, which is goes indefinitely. So such a type of arithmetic progression is known as infinite arithmetic progression. Now consider what are the various properties of an arithmetic progression. See, the first property says that if any constant is added to each term of an arithmetic progression, then the resulting sequence is also an arithmetic progression. See, for example, if we have sequence of numbers that is a1, a2, a3 up to an, then we are going to add a constant, for example k, to each and every element here. Then it will become a1 plus k, a2 plus k up to an plus k. This will also be a arithmetic progression. Similarly, we have second property, that is if any constant is subtracted from each term of an arithmetic progression, then the resulting sequence is also an arithmetic progression. So here we have a given elements, here a1, a2, a3 up to an are the arithmetic progression. Then we are going to subtract a particular constant, that is k, a1 minus k, a2 minus k up to an minus k, which are also a arithmetic progression. The third property says that, see, if each term of an arithmetic progression is multiplied by a particular constant, then the resulting sequence is also an arithmetic progression. So here we have a sequence of numbers and we are going to multiply with a particular constant, here say k. Then a1k, a2k up to ank, which also be a arithmetic progression. And the fourth property, if each term of an arithmetic progression is divided by a constant, then the resulting sequence is also an arithmetic progression. So here with the same elements, see here we are going to divide each elements by a particular constant k, a1 divided by k, a2 by k up to an by k, which are also a arithmetic progression. Now let us see, we want to find out nth term of an arithmetic progression. Let us consider one example or particular situation. You are applied for a particular job and you are got selected. And you have been offered the job with the starting monthly salary of 10,000 rupees with an annual increment of 500. What would be your monthly salary after 10 years? See, if this type of questions will come, then we are generally doing that is 10,000 rupees plus the next year there is an increment of 500. Then next year there is another increment of 500. Then the fourth year again we have another increment of 500. So up to 10 years we have an increment of 500. So in this way, if you are going to find, calculating the monthly salary after the 10 years, it will be a time taking and one of the tedious tasks involving here by adding the increment of the each year. So the 10th year, here we are generally doing that is first year salary plus 10 minus 1, that is 9th year into annual increment. That means we can easily find out by using some equation that is which is generally known as it is an, that is nth term of an arithmetic progression, that is an, which is equal to a plus n minus 1 into d. See, which we are calculated here. An here 10th year salary is equal to first salary, that is a, plus 10 minus 1, that is n. Here it is after 10 year. So 10 year we are considering it is number of period, that is n minus 1 into the how much increment, how much common difference is going on here? It is 500. So by using this particular equation, that is the nth term is equal to, that is a plus n minus 1 into d. See here an is nothing but it is the nth term of an arithmetic progression. A is the first term, n minus 1 is the term position and d is the common difference. So by using this particular equation or particular formula, we can find the nth term of an arithmetic progression. See, by using the same example, now we can find the salary after the 10 year. See, here the first term is equal to monthly salary of starting with 10,000. Here the common difference is annual increment, that is d is equal to 500. Then after 10 years, so here n is equal to 10. Then we can use this particular formula, that is an is equal to a plus n minus 1 into d. See here, all the values are given here, A, N and D is given here. So we are just going to substitute all these values here. Then it will become, that is 10th term of an arithmetic progression is equal to 10,000 plus 10 minus, that is n minus 10 minus 1 into the common difference is here, it is annual increment. So it is 500. So if you go for simplifying it, then 10,000 plus 10 minus 1, it is 9 into 500. So if you can simplify it, it is 10,000 plus 4,500, it is 14,500. So your monthly salary after 10 years will be 14,500. Now consider another example. We want to find out the 27th term of an arithmetic progression, which is starting from 5, 8, 11, 14. And we want to find out the 27th term of this particular progression. See here, A is given, first term, that is 5. Common difference, that is difference between two consecutive numbers. So it is 8 minus 5, which is equal to 3. There is no need to consider the difference between another two consecutive number, because see, in the question itself is given that this is an arithmetic progression. So of course we know that if it is an arithmetic progression, then the difference between two consecutive numbers are always constant. So here D is equal to 8 minus 5, which is equal to 3. And we want to find out the nth term, that is 27th term. So here the formula here, the nth term is equal to A plus N minus 1 into D. So here A is equal to 5 plus 27, N is 27 minus 1 into D is equal to 3. So if you go for simplifying it, it is 5 plus 26 into 3, which is equal to 5 plus 26 into 3, which is 78, which is equal to 83. So the 27th term of this particular arithmetic progression is equal to 83. Now consider another example. Which of the term of an arithmetic progression, that is 21, 18, 15 is minus 81? Which term of an arithmetic progression that is minus 81? So what are the information given here? A is given, that is 21. We can calculate D here, that is common difference, which is equal to the difference between two consecutive numbers. So it is 18 minus 21, which is equal to minus 3. Then the nth term, that is also given, this is minus 81. But we don't know which term is this. So we want to find out this particular term. So n we want to find out here. So here the formula we know, it is an, that is nth term of an arithmetic progression is equal to A plus N minus 1 into D. So you just go to substitute here, an is equal to minus 81, then A first term is equal to 21, but we don't know what actually the n is, which we want to find out. Minus 1 into D, that is common difference, which is here minus 3. So if you simplify here by multiplying these two terms, then it will become minus 81, which is equal to 21 minus 3 into n, minus 3n. Then minus 1 into minus 3, which is equal to plus 3. So here we have minus 3 and plus 3. Now we can simplify it, minus 81, 21 plus 3, which is equal to 24 minus 3n. Now we can isolate 3n here. So here we can subtract the 24 from the both side of the equation. So the 24 will be cancelled out here. Then minus 81 minus 24 will become minus 105, which is equal to minus 3n. We can divide the both side of the equation by using 3 minus 3. Then it will become, see, 105, minus 105 divided by minus 3, which is equal to 35. So this minus 81 is the 35th number or term of an arithmetic progression, 35th term of the arithmetic progression. So in this way we can solve this particular example. Now consider another model of example. See, check whether 301 is the term of the list of numbers which is starting from 5, 11, 17, 23. Here what we want to do? We want to check whether this 301 is the member of this series or not. So in this particular example, see what are the information given? A is equal to 5. D is equal to difference between 11 minus 5, which is equal to 6. Then we are assuming that here 301 is the one of the element. We are treating that is an is equal to that is nth term of an arithmetic progression. That is considering the assuming 301 is a term in this particular series. Then substituting this is a nth term. So here an is equal to a plus n minus 1 into d. So the nth term here it is 301 we are assuming, which is equal to the first term that is 5 plus n minus 1 into, we want to find out this n minus 1 into d, which is equal to 6. Now you just multiply 6 with the n minus 1, then it will become 6 into n, which is plus 6n, then minus 1 into 6, which is minus 6. Now we can solve here 302 by taking the difference between 5 minus 6, which is equal to minus 1, taking into the left side of the equation, so it will become 301 plus 1, which is equal to 302, which is equal to 6n. Now we can isolate the n by dividing the both side of the equation by using 6. Then n is equal to 302 divided by 6, which is equal to 50.33. See here, 301, that is 301 is not a member of or not an element of this particular series, because this not have a positive integer. We need a positive integer without having any decimals. So without having decimal, but here we have a decimals 0.33. So this is not a positive integer. That's why we can say that this particular element is not an element of this given series or not a member of this given series. Okay. Now we have another question. See, find the first three terms of an arithmetic progression whose nth term is given. We have nth term is given, that is an is equal to 2n plus 5, which is, and we want to find out the common difference and the 20th term of this particular series. See, in this particular example, see, the nth term is given, that is an is equal to 2n plus 5. This is an equation to find out the nth term. This is the equation for finding out the nth term. We can find each term from this particular equation by substituting the value for n as a number of terms. So here we are assuming that the first number n is equal to 1. Then we are substituting here n is equal to 1, 2, 3. Then in the nth term of the equation, so it will become a1. We are substituting n is equal to 1. Then a1 is equal to 2 into n. N is equal to 1. So 2 into 1 plus 5, which is equal to 7. So it is 2 plus 5, which is equal to 7. If you are considering n is equal to 2, then it will become a2 is equal to 2 into n, that is 2 into 2 plus 5, which is equal to 4 plus 5, which is 9. Let us consider n is equal to 3, then it will become a3 is equal to 2 into 3 plus 5, that is 6 plus 5, which is equal to 11. Now we can say that these are the various or the first three members of the or first three terms of the arithmetic progression, that is 7, 9, 11. So this is the arithmetic progression, and here the first term is equal to 7 and the common difference, that is d is equal to the difference between the consecutive numbers. So it is 9 minus 7, which is equal to 2. So here the common difference is equal to 2 and the first term is equal to 7. Now we can find the 20th term of an arithmetic progression. The two way we can find out here. See, one way, that is the nth term is already given, that is an is equal to 2n plus n plus 5. So here we can substitute, that is n is equal to 20. So it is a20, which is equal to 2 into, instead of n we are assuming that it is the 20th term, so we are putting n is equal to 20. So it is 2 into 20 plus 5, which is equal to 2 into 20, which is 40 plus 5, which is equal to 45. In this way you can find the 20th term, or you can also find by using the nth term of an, by using the formula for calculating the nth term of an arithmetic progression, that is an is equal to a plus n minus 1 into d. So here n is equal to, again it is 20. So a20, which is equal to, what is a first term, which is 7. So 7 plus n minus 1. So here it is n is equal to 20. So it is 20 minus 1 into common difference, which is equal to 2. So then we can simplify it, 7 plus 20 minus 1, which is equal to 19 into 2. So which will be, it is 38 plus 7, which is equal to 45. So here also we found it is 45. Here also we have 45. So the 20th term of an arithmetic progression, given arithmetic progression is 45. In these two way we can find the 20th term of or nth term of an arithmetic progression. Now consider last example. See, determine the arithmetic progression whose third term is 5 and the seventh term is 9. See, what are the information given here? The third term, that is A3, is equal to 5, and then second one we have seventh term is also given. First we are considering the third term, that is A3 is equal to 5. The equation for or formula for calculating the nth term of an arithmetic progression is equal to an, which is equal to a plus n minus 1 into d. See, if it is so, then the third term we can write, that is a3 is equal to a plus n, that is 3 minus 1, because we are putting here the third element or third term. So it is a plus 3 minus 1 into d. D is not given here and a is also not given here. So we can simplify it, but the a3 is equal to 5. So we can simplify it. See, it is a plus 3 minus 1, which is equal to 2 into d, that is 2d. This is equation number 5. Now consider the second information that is given here. The seventh term of an arithmetic progression is 9. So here the seventh term, that is a7, is equal to 9. We can write it. It is seventh term, that is a7 is equal to a plus 7 minus 1 into d, which is equal to 9. So here we can simplify this one, that is a plus 7 minus 1, which is equal to 6d, which is equal to 9. So this is the second equation. So we have two equations here, that is first one and the second one. We have a simultaneous equation with the two unknown variables, that is a and d. So the first equation is here a plus 2d, which is equal to 5. Then the second equation is a plus 6d, which is equal to 9. Now see, the first term, that is a, is common here. The coefficient is 1, here also 1. So we can just subtract the equation number 2 from equation number 1, so that a can be cancelled out. So we are subtracting here. So a will be cancelled out. Then 2d minus 6d, which is equal to minus 4d. Then 5 minus 9, which is equal to minus 4. Now we are dividing the both side of the equation by using minus 4. Then it will become d is equal to 1. D is equal to 1. If d is equal to 1, then we can substitute d is equal to 1 on the equation number 1 or equation number 2. We are assuming here, we are substituting d is equal to 1 on equation number 1. Then it will become, see, equation number 1, that is a plus 2d is equal to 5. Then we can substitute d here, it is equal to 1. Then a plus 2 into 1, which is equal to 5. So if you go for simplifying it, a plus 2 into 1, which is 2, which is equal to 5. Then we can isolate here the variable a. See, by subtracting the 2 from the both side of the equation, then a is equal to 5 minus 2. So a is equal to 3 here. So the first term of this arithmetic progression is equal to a, and the common difference is equal to 1. And we want to determine the arithmetic progression here. So here the first term is equal to a is equal to 3, and the common difference is equal to 1. Then the arithmetic progression, hence here, see, it is 3, first term is equal to 3. Then common difference is 1, so we can add 1 to the 3, then it will 4, 4 plus 1, which is equal to 5, 5 plus 1, which is equal to 6, 6 plus 1, which is equal to 7, and so on. So here the arithmetic progression is 3, 4, 5, 6, 7, and so on. So this is the solution for this given question. So let me conclude here. Today we introduced the concept of arithmetic progression and then discussed how to find the nth term of an arithmetic progression along with some numerical examples. I hope it was clear to you. In the next lecture, we will discuss how to find the sum of n terms in an arithmetic progression. We will see in the next lecture. Thank you.